Hello, I'm Robert Falzon with Checkpoint Software. Thank you for joining me today. I'm going to be talking to you about surviving the digital storm or the IoT security deluge. So we think about how isolation has been treating us. I mean, it's been quite a while in lockdown now. I'm wondering sometimes how we would have managed the situation, say maybe back in the 70s when the technology landscape was a little bit different than it is now. We have all this awesome entertainment technology. We have toys and we have all sorts of things like iPads and Netflix and so forth to entertain us. I can't imagine life without it, especially being stuck in my house for months at a time. Now, it's interesting because all of these technologies are incredibly useful and certainly entertaining, but what are they really? How are they permeating our everyday life? Well, it's invaded every aspect of our lives, really. And we look at some of these things, it's in the most personal of ways. So if it's for the ease of adjusting the environment around us from the couch, or maybe it's determining whether there's beer in the fridge while I'm already out at the store shopping, I can look inside my refrigerator remotely. Maybe it's just keeping the floors clean, keeping the pet hair out of the air, or even just keeping us company. There's a lot of things like personal robots and things like that as well. Either way, these smart devices that empower all these technologies are part of the Internet of Things. And they have exploded onto the world at an unprecedented rate. So let's talk a little bit about how that explosion has looked. And it creates an immense issue of scale. The fact is that the number of interconnected smart devices is exploding. And if we look at the numbers, say back in 2016, we're somewhere between 16 and 18 billion devices. So billion with a B, that's still an incredibly large amount of devices. But if we look at where these projections are going, they're looking at somewhere in the neighborhood of 85 billion devices. So that's really quite phenomenal when you think about just how many devices that is, and try to get your mind around what that what 85 billion devices looks like. Maybe it's easier to look at it in terms of individual devices. So that boils down to somewhere around the neighborhood of 127 devices being connected every single second. It's an incredibly large amount of devices. They are finding themselves in the most critical places as well. So for many of us who are, finally breaking out slowly out of our confinement from COVID, perhaps we're looking to go for a drive, or maybe we're fortunate enough to be considering the possibility of a new vehicle. By 2023, 75% of all automobiles that are sold will be connected to the internet. That's a really incredible number, including technologies that allow us to connect those after the fact if they weren't enabled by the manufacturer. Now, if you are looking at buying a new car, there's a very solid chance that that new vehicle may even have an autonomous drive system associated with it, which is really, really incredible now. Again, go back to my 70s comment. Imagine getting into a vehicle back then and taking your hands off the wheel and allowing the vehicle to drive us around, and entrusting our not only ourselves but our families to this technology. This technology hasn't been around that long, and if we knew really how vulnerable many of these systems are, it maybe will give us cause to pause that thought for a minute and think about where we're going with how we protect ourselves in this new world. Certainly, we're trying to keep ourselves safe, and those technologies that we're talking about have been keeping people safe for a long time in other different arenas. For example, let's look at where they came from. So manufacturing was obviously took huge advantage of the IoT revolution, which really helped us with the industrial revolution. The technologies are on a broad scale. They really they help us in farming and in the dairy industry. We find them from an industrial sense in all sorts of different manufacturing capabilities. Say, for example, in many parts of Canada, they're used to keep wellheads safe by monitoring the pressure, make sure there are no leaks or any sort of spills or anything like that, which are obviously critical to the environment. Perhaps these devices are being used in manufacturing in places where we're protecting people from dangerous equipment. Say welding is a great example where these tools and technologies play a major part. Also in the generation of electricity. Nuclear power plants, certainly we think of when we think internet connected devices as far as sensors and things like that are concerned, and safety systems, but also even legacy systems like our water delivery and so forth. A lot of those systems are not only run by IoT devices, but they also may be legacy. Some of these systems have been in place for 10, 15, maybe even more years. And they were really not designed to be used the way we're using them today. Now, if I'm thinking about criticality, the final and probably most critical one I can think of is the healthcare system in our healthcare industry. If those who can remember WannaCry, it wasn't that long ago, it makes me want to cry. It hit many of the medical systems around the world, including the National Health Services in the UK, practically brought them to a standstill. In the middle of the COVID crisis, a hospital in Czech was hit. They had to shut down and evacuate the hospital. Interpol even issued a purple notice to alert law enforcement in all of its 194 countries that to support basically the global fight against cyber criminal and behavior related to these types of devices. There really is no honor among thieves, and they are definitely willing to attack us in our most vulnerable. In fact, it's the most profitable time to do that. Hospitals and any other number of industries, especially during COVID times when these systems are truly critical, when we think about testing and so forth, it's a great opportunity for those more nefarious of the hacker community to try and take advantage. If we look at healthcare itself from an expenditure perspective, by 2024, it's probably going to be somewhere in the neighborhood of $140 billion in expenditure on these types of technologies. So that's a significant number, obviously, and it brings to bear the next challenge with these things. That is that all of these devices are being connected to the internet, as we mentioned before, or to other sort of interconnected networks. Now, one thing that isn't talked about a lot is what is the next stage of this sort of data deluge that we see as well. And that is really the emergence of AI and the big data players. So companies like Microsoft, Amazon, Google, they're obviously looking to leverage artificial intelligence for their IoT plays. They're looking to aggregate that big data and make sure that that information is obviously collected, packaged, and resold to their customers. So it's of significant value. Unfortunately, much of this data comes from not only sensitive systems, but also sensitive companies. And it may not be something that many organizations are or would be comfortable in sharing if they knew how easy it was to collect this info. Now, security solutions that we're talking about moving forward must be able to manage the flow of this type of data. And that obviously represents one of the significant challenges now that we are seeing these systems being connected to the public internet space. So I get asked sometimes, how significant is the risk if I'm looking at whether these devices, could these devices be hacked from the public internet? Maybe I have some security controls in place. So that question was posed to the Department of Homeland Security in the US. And several years ago, they commissioned a study, and they worked with a university in Colorado to determine whether or not it was feasible to assume an attack could originate from the public internet and that they could actually attack a physical piece of equipment in, say, a power generation station. So what I'm going to do is quickly play a video for you. And this video is going to show you an actual attack that took place. It was known about. It was something they invited white hat hackers to do, to come in and try to take advantage of this power station. And in doing so, they recorded it to see whether or not hackers could actually have an impact on a physical piece of equipment from the internet. And this is the result. I'll play this video for you now. So as you can see from that example, it is not only possible to imagine it, but it's actually been proven in a proof of concept. So to see something like that obviously is fairly jarring, and it can be startling, obviously, to think that that's possible, but there are several reasons why that is. And I'm going to talk about some of the challenges that impact our ability to do something about this. So the first one I'm going to talk about, as I mentioned it before, is the scope. the scope and complexity. There are just so many of these devices that managing them in a way that we used to manage the devices in general is really kind of impossible. There are just far too many of them. I'm not going to be creating an IP address for 100 or 25 or 30,000 devices in a hospital network, for example. The second one is the inherent vulnerabilities that are in these platforms to begin with. Now, when I talk about inherent vulnerabilities, many of these devices are developed or were developed at a time when the types of security incidents or the types of attacks that we see now could not have even been imagined at that time. And these devices were never meant to be connected originally to this type of network or to have this type of access. Next, we talk about platform diversity. When we talk about IoT devices, there are just a huge multitude of types of devices, everything from, if you think from cameras to insulin pumps to train switches or pressure valves or control systems. There are just so many, and they're so diverse from so many different industries. To imagine trying to have somebody know about all of those makes it obviously not only a significant challenge, but virtually impossible. Next is the issue of criticality. As I mentioned before, these devices and systems find themselves in the most critical areas of our deployment. They're in the safety systems that we deploy. They are, as I mentioned before, they are responsible for helping our family, driving our families around in our cars, or they might be responsible for delivering medicines to our bodies directly via insulin pumps and things like that. So the nature of criticality also makes it not only critical, but challenging to make sure that we do this properly. Now, why are solutions we're seeing today not up to snuff? And there are a number of reasons for that too. So legacy solutions typically fail for three primary reasons. The first one is there really is very little or no risk visibility. We don't really know what the challenges are with these devices. Perhaps they were developed, very quickly or rapidly and deployed and marketed, sold, and implemented in such a way that we don't have visibility into their firmwares. We don't know how they were developed. We don't know what libraries were used in the software and so forth, or whether there's vulnerabilities inherent in them. There's also a significant knowledge gap. So the same individual who may have a great deal of knowledge on many of the legacy systems and devices existing perhaps in a power plant may not really understand the nuances of cybersecurity in general. So as a result, those become really kind of two different people, and you must now rely on collaboration and so forth. So there's a tremendous knowledge gap in staffing to make sure that we have the appropriate people in place to help us resolve these problems. Finally, there's generally no threat prevention. Many of these devices, because they were not meant to be connected to the internet, suffer from the lack of tools, basically, to protect themselves. So as a result of that, they are left inherently vulnerable because we're not applying the same systems and softwares that we are using for our enterprise networks to protect our OT networks as well. Okay, so we have to start thinking about this in a different way. So how are we going to do that? Well, we have to start thinking about building these solutions from the ground up with IoT in mind. We have to think differently. We have to design it differently from the start. So one of the important things, what can we look at that would help us with that scenario? Well, we could look at IoT risk analysis first of all. We have to understand what these devices are and where they're located. We also have to understand whether or not we have to understand that we can't manage these things in a manual way. We have to look at automation and the auto generation of policies and the implementation of real threat prevention technologies, the same types and standards that we would expect from our enterprise protections as well. So these need to be applied to our IoT and our manufacturing device networks in the same way. So let's look a little closer at what these types of solutions might encompass. We're going to start with the three primary areas where I think we can have a huge impact on this challenge. Firstly, it's in the area of discovery. When I talk to customers, I'll use the example of healthcare again. If I go into a hospital and I ask them, can you tell me how many IoT devices you anticipate are on your network today? And they might come back and tell me, between 10 and 15,000 devices. Well, from my experience, it's typically much more than any answer that they would give me. And there are several reasons for this. Sometimes these devices may be set up in such a way that they have multiple ways to access the network. They might have both LAN access, but they also might have some sort of low power radio or Wi-Fi or Bluetooth even connected to them as well, which provides additional connectivity capabilities. So there's also the problem of, as I mentioned before, the risk of firmware itself. So when these devices are developed, they obviously have very small memory footprints. They're put into places that are often very ruggedized environments or harsh environments. We're not familiar often with the types of code that is being used to basically place in the firmware that runs these devices themselves. As a result of that, because we don't have that visibility, we find ourselves subject to inherent security flaws and other known vulnerabilities that may exist within the software itself that runs those devices. And finally, we need to look at applying the same globally shared threat indicators that we would use for our enterprise and our, for example, our laptop environment, and use those same technologies and apply them in a way that allows us to take advantage of those threat protections in our OT environment. So how would we look at doing that? So if I'm going to talk about the devices themselves, let's focus there for a moment. When I talk about a device itself, as I mentioned, the great vast array of devices that we might be talking about here, I'm going to select one in particular. I'm just going to use a camera. I pick a camera because, for example, in a manufacturing place, maybe they'll be looking at investing in a new robot. So maybe they'll bring that robot in and put it on the network as part of a POC to test and determine whether or not they would actually like to use this robot in their environment. In doing so, we now would be able to look at that device. So in this case, we're going to look at this camera, and we can see several different areas where we can gather quite a bit of information. First of all, we know that this camera probably has weak or known credentials. Any device that's delivered from a commercial perspective often has a set of defaults in it. Those defaults are widely known. There are tools available online that you can use to search for devices that are configured with their defaults and then plugged into the public internet. Places like Shodan, for example, you can go on there and you can say, show me all of the known SWAN cameras, for example, that are on the public internet. And it will show you those, and you can proceed to browse around and view other people's camera footage. There are other issues like known vulnerabilities, as I mentioned before. Manufacturers are often pressed to get these products to market very rapidly. And as a result, they may be tempted to, for example, use reshared code libraries that other folks are using as well. This introduces other inherent risks because that software may already have vulnerabilities inherent to the shared software components that they're using. And as a result of that, they're introducing those vulnerabilities to their new product. Of course, software misconfigurations, the leaving on the Bluetooth when it shouldn't be necessary, or turning on some other sort of connectivity or backdoor, for example, could be configured when it's actually not necessary. And as a result, it opens up a risk certainly in that product. So seeing that the risks that this particular camera has, what we need to do is really start looking at applying this camera a risk score, right? Just like we would any other risk in our environment. So a risk score allows us to determine something like, where should this camera sit? When I talk about risk scores and where this should sit, I'm talking about policy now. Generally, when I talk about IoT in general, I'll start my presentation by asking how many people have a policy for light bulbs. And I ask that because if you don't have a policy for light bulbs and somebody installs a bunch of smart light bulbs in your network, these can be exploited. They can be used as Wi-Fi pineapples or man-in-the-middle devices and so forth. But if you do have a policy for light bulbs and you can place those light bulbs in that policy the minute they're detected on the network, now you have a pretty solid foundation for making sure you're protecting yourself and your IoT devices. So this particular camera has a risk score of high. We know that it's a risk. So what we'd like to do is, after detecting the camera, identifying those key points that I pointed out in my previous slide, then assigning it this risk score, I can then add it to a real-time policy automatically. In doing so, now I have protected myself, and I've made sure that this device is not able to access resources or areas or fundamental points in my network that it shouldn't, right? So it's basically bringing this device in line with the types of policies that I already have for the rest of my network. So using a single pane of glass now, I'm able to bring all of this information into one consolidated log, for example, which now allows me to also do forensics on this new data that I have. So obviously you can imagine this is very powerful. It's not just for cameras. As I mentioned before, we can look at any amount of devices that we can detect and determine whether or not those devices have risks, what they are, assign them a score, and then put them automatically into policies that you select or have selected ahead of time. Right? So now how many people would be interested in having a security policy for light bulbs, perhaps at their house? Okay. Now, obviously, as I mentioned before, logging and analysis is critical. It's often a part that's overlooked, and including logging and analysis for these devices into our overall security posture not only improves the security itself, but also gives us more visibility into perhaps the health of our IoT network in general. If we see a number of issues or a number of outages, it may not just indicate an issue with a cyber attack of some kind. It may even be an issue with some sort of performance related item too. So this is, has benefits beyond just the security aspects of it. Now, let's look a little bit further at the devices themselves. So as I mentioned before, determining whether the firmware is at risk itself is also hugely important. So what we have developed at Checkpoint is actually something called nano agents. And what they allow us to do, it's device runtime protection. So what it does is it monitors the behavior of the device at runtime, and it allows us to block known and unknown device level attacks before the device is actually compromised. So things like memory corruption or flow integrity attacks or shadow stacks or shell injections or anything like that. These types of examples are ways that we have seen other devices exploited in the past, and typical modes of exploit for anyone who's looking to take advantage of an IoT device. Now, by applying these protections in real time, they also bypass one other significant challenge in these networks, which is, say, older hardware and older equipment. Maybe these devices are vulnerable but can't be patched. Perhaps there's no firmware updates available for them. So by protecting these devices in real time and applying these types of patches immediately in real time, we protect ourselves from those unknown attacks before they hit our network. Now, because these devices, you can imagine, are found all over the place. I mean, if we look at IoT devices in the public space, they're everything from our parking meters to, grow operations at farms. They're found in our hydroelectric systems at home to help with our billing. And imagine driving down a street in the middle of the evening and all the street lights shut out. Or like that happened in Texas, where in one town had every single one of their air raid sirens go off at 2 in the morning due to an exploit. These types of things can be significantly challenging, and many of them are due to flaws within the devices themselves. So by protecting against that, we have a significant impact on our risk. Now, let's talk a little bit about deployment. So many folks are challenged with, how would something like this be put into place? Well, it's actually quite simple. The installation mirrors that of a typical firewall management type of environment that you're already familiar with the difference being we also work with a number of partners like Order or Aramis to basically, or Medigate is another great example in the medical field, to basically help us identify all of the devices in the network, and then identify any patches or any sort of vulnerabilities that may exist, and then apply those in real time to that device network. Now, many are also probably concerning themselves with, well, Robert, I typically already uncomfortable with connecting my OT network to my IT network, so even if it's for the reasons of security, but I'm going to help you with that as well. So when we look at how that's done, what we've done at Checkpoint is using other technologies like localized security orchestrators and data diodes. We're able to push all of these protections down to a local repository at the level of the organization itself. From there, then those nano agents will collect their information from what we call fog. It'll collect it from that security cloud within the organization itself. So all of these protections, the anti-bot, the network IPS, device workload protection, and web application and API protections, all of the types of things that we would expect in our IT network now, all of these protections are now being applied in our OT network as well. And it's very, very simple. And certainly we want to talk about what about, how do I use this perhaps if I'm not a Checkpoint customer already today? Well, it's actually quite simple. So because Checkpoint has and is a software company and has been since its inception, all of these services and softwares we're talking about are in our software. As a result of that, our move to the cloud has been rapid and very, very successful. And as a result of that, you're actually able to do a demonstration of this product yourself in your environment and very simply. As you can see here, this is actually our new Infinity 2.0 portal, which allows you to actually implement many of these technology solutions that I mentioned earlier in my presentation yourself online in a very, very short period of time. So here you can see us activating the platform. This is simply a web page that you're looking at here. And once I've done so, I can actually do things like configure visually the types of policies and the best practices for my IoT environment, and I can apply those rules directly to my devices. So what you're seeing here on the screen here is actually a CCTV example where the closed circuit TV devices are only allowed to talk to the DVR and the cameras, for example. Right. So again, this is all based on a web application. So being able to run this from your certainly from the comfort of your management location makes it a lot easier, and certainly it's a lot safer than many could realize. So what I hope you've learned from this is that we are moving towards an autonomous, scalable, non-disruptive security solution for your IoT networks and your IT networks. And I hope this presentation has been useful. And if you have any questions, please do feel free to reach out to me offline, and I'd be more than happy to help you with them. Thank you.